Bismillahirrahmanirrahim. Assalamu alaikum dear students. Welcome to the second week's lecture of wireless communication system. I'm hopeful that every one of you is safe and sound, and I'm hopeful that you have reviewed the lectures of first week. Before I start today's lecture, let me quickly review what we briefly discussed in our last week lectures. In our last week lectures, we talked about some basic concepts of wireless communication systems, and we discussed that wireless communication systems they are attributed with the signal propagation through free space. The transmitter antenna converts the incoming signal from transmitter into electromagnetic wave and send it over a free space, and the receive antenna collects that electromagnetic wave and convert it back to the electrical signal to deliver to the receiver. Secondly, in our last week's lecture, we talked about some fundamental terminologies and basic architecture of wireless systems, and we discussed that there are different components that are working together. They are interconnected in order to establish a large network. The mobile equipment is at the user side, and the base station is connected to the mobile equipment. The base station is connected to the MSCs at the back end, and MSCs are connected to the PSTN to provide coverage to the larger areas. Third thing that we discussed in our last week's lecture were regarding the evolution of wireless systems. The wireless system, they gradually evolved from its first generation and to its current state, which is about to start in fifth generation of wireless systems. So we have the wireless systems, they have evolved from first generation to fifth generation, and still this evolution is under process, and a significant amount of research work is being done in this area to further improve our wireless system. Secondly, we talked about some of the examples of wireless systems, and we briefly talked about cordless phones and paging systems, and we briefly discussed cellular systems. In today's lecture, we are going to further discuss the cellular system. The concept of cellular system is actually very important in today's wireless architecture. The modern wireless systems, they are based on the cellular architecture. The modern communication systems, as I said, they are based on this wireless cellular architecture. So it's very important to understand how these cellular systems they work, and they can give potential improvement in the capacity of a wireless communication system. Before we start discussing cellular architecture or cellular systems, let me discuss the non-cellular system, how the non-cellular or old mobile phone system was supposed to work. The first generation mobile phone systems were basically developed as non-cellular architecture, and they were designed to provide coverage to large cities only. So if you look at the figure here, if you see, this figure shows an antenna. It's a large tower which is supposed to be located at a central point in a city. The tower is equipped with omnidirectional antennas at the top. This omnidirectional antenna provides coverage in all directions around. Generally, this cellular tower, they are designed to operate with very high power so that the signal can propagate to a large distance. Therefore the coverage area is relatively very large as compared to cellular systems, but this large coverage area is of the order of around the radius of that coverage area is of the order of 50 kilometers, and you can imagine 50 kilometers radius can cover an entire city. So primarily one tower was capable of providing coverage to an entire city. So the number of channels or number of users that are available with that tower, they were supposed to provide coverage to all the population in that particular area where this tower is deployed. If there are other cities which need coverage, so we need to install other towers. Similar towers should be installed in every city. So if you look at the figure below, you can see there are 4 cities represented in that figure, and each city is being served with a separate tower. There are few important things that need to be highlighted in this situation. First thing, you should note that the entire spectrum is available to the entire city. Like for example, if you have 40 megahertz of allocated band for the communication systems, so this 40 megahertz band is available in city 1, as well as the same band is available in city number 2, the same band is available in city number 3, and same band is available in city number 4. The same frequencies and the same channels are being used in city 1, city 2, city 3 and city 4, but still there will be almost no interference in those cities, because the cities are supposed to be farther away from each other. So you can see that the distance between city 1 and city number 4 is very large as compared to the coverage area of each of the mobile tower. So the city 1's mobile tower has coverage to a certain extent, which is typically a circular region around the mobile tower. Similarly, city number 2, it has coverage in certain region around the mobile tower of city number 2, and in between these two there is a region where there is no coverage. So the user here in the region between city number 1 and 2, it will not be able to get any coverage from the tower of city 1 or from tower of city 2 or any other tower. So it will not be getting any coverage from any of these. So this system is associated with several problems. If you closely look at the problems associated with these old mobile phone systems which are based on non-cellular architecture, so we see that there are 3 major categories of problems. First problem is that you do not have continuous coverage. As I showed in the previous diagram, you have coverage in the coverage area of city 1, you can get coverage in city number 2, but in between city 1 and city 2 there is no coverage. So there is a region where the active users will not be able to continue getting the service, because the coverage areas are actually non-overlapping. So once you go beyond the limits of the coverage area of a city, you will not be getting any service. Second important problem is related to the capacity of the system. In United States, for this old mobile phone system, first generation mobile phone systems, the total allocated spectrum was only 40 megahertz, and each channel was allocated for a bandwidth of 30 kilohertz. That means in order to establish a full duplex communication between users, you need to have 60 kilohertz. That is one 30 kilohertz channel for uplink communication and one 30 kilohertz channel for downlink communication. So eventually each user require a bandwidth of 60 kilohertz. And from this perspective, if you calculate, you can see that in that scenario, the system can only accommodate 660 users simultaneously. So this coverage is extremely low as compared to the population of a large city. You can imagine a city that has a population of 1 million maybe, and out of those 1 million population, you are providing coverage to only 660 users. So eventually the system was not did not have the capacity to accommodate all those systems, and system got congested very easily because it was based on a very limited spectrum, and more users were not able to use that spectrum there because of that is being already used by already subscribed 660 users. Third thing which is associated with these old mobile phone systems is the battery requirements. You can see that a mobile tower is actually extending its services to a large area of the order of 50 kilometers. So you can expect a mobile station would be around at a distance of 50 kilometers from the base station, and the power needed for that mobile station to transmit the signal to the distance of 50 kilometers is large. So generally mobile phones, they have to transmit at very high powers, and for those high power requirements we needed large batteries. So eventually those mobile phones, they were very large in size and they were inconvenient. And if you go to internet and try looking at some old photos of mobile phones, so you would see a large box which is carrying the battery of the mobile phone, and a large handset which is used to establish communication. So those mobile phones were having a large battery requirements, which caused the system to be very bulky as well as inconvenient. Considering all those concepts, all those problems that we discussed with old mobile phone systems, the AT&T Bell Labs, they introduced a new concept which is now known as cellular concept. That cellular concept was basically introduced in late 1960s, but actually the practical deployment was not achieved in 1960s because the hardware was not available to support that cellular concept, and so that cellular concept became a reality in around early 1980s. So basically the concept is old, but the physical deployment was around 10 years later when the proper hardware was available. So what was the cellular concept? AT&T proposed that we should not use a high power transmitter. Instead, what we should do, we should replace that high power transmitter with low power transmitters. Of course, if we use a low power transmitter, the coverage area would shrink. So as you talked for first generation mobile phone systems, the coverage was of the order of 50 kilometers. But once we start replacing the high power transmitter with low power transmitter, the coverage radius get smaller. So as you keep on reducing the power, the base station will be providing coverage to even smaller region. And how do we provide coverage to entire area? In order to do that, we have to divide the entire region into small portions, small regions, and those regions were named as cells. So we need to provide cells. So each entire larger coverage area was divided into smaller regions, and each small region was equipped with a base station which is designed to provide coverage in that particular cell only, that is a smaller portion of the entire area. So the each base station is low. So in that case we will be needing more than one base station to provide coverage to a larger area. And secondly, the second important thing about the cellular concept is that we should each base station should be allocated a portion of available channels. Uh, for example, if you have 40 megahertz bandwidth and you have you can say that 40 megahertz bandwidth was capable of providing 660 communication or 660 channels. So if we are going towards cellular concept, we have to assign around a smaller number of channels to each cell. So one cell may be assigned you can say 120 channels, another cell may be assigned 120 channels, and so on. So we assign a smaller portion of the channels to each base station providing coverage to one cell, and we should take care that nearby base stations they should be assigned different channels, because if we assign two nearby base stations are assigned same channel or same channel in same frequency, they would cause interference with each other. So in order to reduce the interference, the nearby stations has to be assigned with the different group of channels. So basically the cellular concept was a breakthrough in solving the spectral congestion problem and the capacity problem because it provided an alternate way of utilizing the frequency. So actually the concept is that we can if we provide coverage, the base station provides coverage to a smaller region, so eventually it will be the radiations will be limited to that particular cell or that particular smaller region, and any other cell which are at a larger distance, it will be having limited or no interference with that particular cell. So the other region can reuse those frequencies to establish communication in that particular cell. So this cellular concept was associated with another important concept which is known as frequency reuse, that I am going to elaborate in my next slide. This frequency reuse has offered a way to achieve high capacity in a limited spectrum. So the available spectrum was limited, but with that limited spectrum we were able to achieve relatively very high capacity which was not possible with the older mobile phone systems. But one important thing is that because we are trying to use the same frequency at two different cells, we should design the system in such a way that there is no interference, and this is achieved by placing the channels, reusing the frequencies in the cells which are not close to each other, or so eventually you have to assign different groups of channels to the neighboring base stations. Let me try to elaborate that thing with a simple diagram. So you can assume that we need to provide coverage in this red area. This is our city area where we want to provide a coverage. So what we do, we divide the entire area into smaller regions. So these lines or numbered areas, they are smaller portions that we are naming as cells. So we have divided the entire city into say 21 cells. You can see that one cell, for example cell number 1, It has boundary with cell number 2, it has a boundary with cell number 4, and it has a boundary with cell number 3. So cell number 2, 3 and 4, they are neighboring cells of cell number 1. But cell number 7, it does not share any boundary with cell number 1. So if any frequency is assigned to cell number 1, the same frequency can be used in cell number 7. For example, let me give you a case where we assign frequencies which are not suitable for cellular communication. So it's basically a counter example that we use in these days. So it's just to illustrate how we can improperly assign the frequencies in a cellular system. Say for example, we have 4 frequency groups. A is a group of channels, the B which is another group of channel, C is another group of channel, and D is another group of channel, which are shown by 4 different colors. And we assign each group to different cells in that particular region, as we discussed in last slide. And you can see that there are certain cells which are assigned frequencies, but they are sharing boundaries, they are adjacent. For example, take a look at cell number 2 and cell number 7. Cell number 2 is assigned the group C of channel frequencies. Cell number 7 is also assigned group C. So any mobile which is at the boundary, it will be getting signals from base station number 2 as well as base station number 7. Eventually there will be very high interference at these two cells. Similarly, if you look at cell number 12, 15 and 19, they are also sharing boundaries, but the same frequency band is assigned to them. 12, 15 and 19 are same frequency groups which are assigned to 3 different cells, which are cell number 12, 15 and 19. And eventually any communication which is being taken place at that particular cell would be affected by high interference from the neighboring cells. So if any mobile is communicating with base station number 15, it will be getting signals from cell number 19 which will cause interference, as well as signals from cell number 12 which will cause interference. So this one was an example where the cellular system would not work because of the high interference from neighboring cells, and this is caused because we did not properly assign frequencies to different cells. Let us correct the frequency assignment. Here is another case where we have carefully assigned the frequencies, and we took care that neighboring cells, they should not be assigned same frequencies. So if you take any case, for example, I focus on cell number 17. Cell number 17 is assigned the frequency group A, and neighboring cells, which are cell number 20, cell number 18 and cell number 16, they are assigned different groups. 20 is assigned D, 18 is assigned B, and 16 is assigned group C. There is another cell 19 which is assigned the same frequency group, which is assigned to 17, but they are far away. Any signal which is coming from 17, because of the larger distance, it will get to a very minimum power level, so the interference caused by that particular signal will be minimal. Similarly, the same frequency is reused in cell number 7 and cell number 1 and cell number 11. So you can see that if we look at frequency group A, the frequency group A is actually used in 5 different cells. Similarly, frequency group B is also used in 6 different cells, and frequency group C is also used in 5 different cells, and frequency group D is also used in 5 different cells. And each assignment is made in such a way that the groups which are having same channel, same frequencies, they are not adjacent, they are not neighboring, they are not sharing any boundary with each other, so that they do not get interference from the other base station. So in from this you can see that this entire region is actually using same frequency group A, you are able to establish 5 different communications. So eventually the entire capacity of the system is increased 5 times. So you will be having higher capacity on the cost of more base stations, because instead of one base station, now we are deploying 21 base stations with smaller transmit powers. So we can by using this cellular concept, we can reuse the frequencies in faraway cells in order to increase the overall capacity of the system, provided that we restrict ourselves to that limited spectrum. So summarizing that we discussed right now, we can reuse the frequency groups in faraway cells. If we are using in faraway cells, there will be little or no interference, because the distance is high, is large, and this signal coming from a faraway cell will be at relatively low power and would not cause significant amount of interference. Because secondly, because we are reusing the frequency over and over in the same region, the capacity of network can be increased many times. It depends on how many times of frequency is reused in a particular region. So if as we increase the reuse of frequencies, the overall capacity would be increased. Secondly, a third important thing is that we are restricting the transmission to a smaller region that may be of the order of 3 or 4 kilometers. If we are transmitting our signals to a smaller region, eventually the cell phones would not require to transmit high power. So if they do not require to transmit high power, so we do not need large batteries. So eventually the need of large batteries would not be there if we restrict the communication to a smaller region. So we can design the system with smaller batteries, and this cellular concept enabled us to build smaller cell phones by replacing large batteries with the smaller ones. The important thing is that this concept increases the capacity without increasing the demand of the spectrum. So if we need to increase the overall capacity, the demand is increasing, so what we need to do is to make more smaller, even smaller cells. As we add up more cells in the region, we will be having more frequency reuse, and eventually it will end up with higher capacity. So this concept, this is the fundamental concept actually which form the basis of modern wireless communication systems. You can see that by reusing the frequencies, we can accommodate arbitrary number of subscribers in a coverage region without actually involving the need of larger spectrum. There are a few important things related to the cellular concepts. First important thing is that we should use the frequencies in such a way that we should reuse the frequencies in such a way that the neighboring cells, they are assigned different channels or different frequencies. If we do not assign the different frequencies to neighboring cell, eventually we will end up with interference. So in order to avoid interference, it's extremely important to allocate different frequency bands to each neighboring cell. Secondly, The base stations, they should be designed in such a way that they should provide coverage to the specific cell only. So the power requirements and all other requirements for the base station should be in such a way that they only restrict their services to a specific cell. They do not transmit such high power to cause interference with others. So eventually, if we restrict our these two conditions and carefully design a system, so we can reuse frequencies in the coverage area by keep the interference level to the tolerable limit. Eventually, this reuse of frequency results in overall increase of the capacity of the system. The design process of selecting and allocating channel groups for all the cellular base station within a system is known as frequency reuse or frequency planning. So frequency planning or frequency reuse is a concept that we were discussing in previous slides. One thing that I want to point out is that the coverage of base station is actually determined by field measurement or propagation models, and generally it's random. So each base station provides coverage to a specific region, which in our terminology is known as footprint. So footprint is actually the region which is representing actual coverage region of a base station. So here is a conceptual diagram representing the reuse of frequencies in certain area. You can see that we have area which is represented here, and we have divided this area into 21 cells, but there are 7 frequency groups. You can see there is a group A, B, C, D, E, F and G. There are 7 frequency groups which are allocated to 21 cells. So each group is reused at 3 different locations in this conceptual diagram. You can see this bold line which is actually comprising of a group of all possible frequency channels A, B, C, D, E, F. So this is actually one single use. All channels are of all the channels. So we call this bigger portion as a cluster. So cluster is actually a region where we have distributed all the channels. A cluster generally comprises of a number of cells. For example, for this particular case, a cluster is made of 7 cells. So the cluster size is 7. You can see that we have divided the entire spectrum, frequency spectrum, into 7 portions. So each cell is allocated 1/7 of the total frequencies available or total channels available. This number is known as frequency reuse factor. So in this particular example, the frequency reuse factor is 1/7, which because each cell contains 1/7 of total number of available channels. Okay. So this was a basic introduction regarding the cellular concept and how we use that concept to reuse the frequencies. So let us conclude today's lecture by taking a simple problem. So let us see, we have a simple problem here. If a total of 33 megahertz bandwidth is allocated to a particular FDD cellular system which uses two 25 kilohertz simplex channels to provide full duplex voice or control channels. We want to compute the number of channels which would be available per cell if a system uses a 4 cell reuse, a 7 cell reuse and 12 cell reuse. So we have 3 cases. in one case the cluster size is 4, in other case the cluster size is 7, and in third case cluster size is 12. And we have another condition that if 1 megahertz of the allocated spectrum is dedicated to the control channel, so what will be the distribution of control channel and voice channel for these three cases, that is 4 cell reuse, 7 cell reuse, and 12 cell reuse. So if we look at the data which is provided in this problem, you can see that the total available bandwidth is actually 33 megahertz. But in order to establish a duplex communication, we need to use 2 simplex channels, and each channel is of 25 kilohertz. So eventually we would be needing 50 kilohertz for a duplex channel. So that means the total available channel in this particular case will be 660 channels only. So if we have a cluster size of n is equal to 4, then how many channels will be available per cell? You can simply divide this 660, which is total number of channels, by the cluster size, which is 4. So we will be having 165 channels available for each cell in a cluster architecture of 4 size. Similarly, if we have cluster size of 7, in that particular case the total number of channels which would be available in a cell would be approximately 95 channels, and if they are obtained directly from the data that we have 660 possible channels, and we want to divide those 660 channels into 7 different cells. Similarly, for cluster size of 12, we want to divide those 660 channels into 12 different cells. So eventually each cell will be getting 660 by 12 channels, that is 55 channel. So you can see that if we are increasing the number of cluster cells, n is equal to 4, 7 and 12, so eventually we will be required to distribute the channels to more cells, and eventually each cell will be getting smaller portion of the channels according to the cluster size. Okay, now let's come to the second part. What if we have allocated 1 megahertz spectrum for control channels? 1 megahertz means 1000 kilohertz. So if 1000 kilohertz is allocated for control channels, so there will be 20 control channels. 1000 divided by 50 is actually 20. So that means out of 660 total channels, we are using 20 control channels, and we are left with 640 voice channels. So what we need to do is to divide 640 voice channels and 20 control channel in the cluster. So for example, if we take the case of 4 cell clusters where we have n is equal to 4, in that case 20 channels, if we divide into 4 clusters, so 5 control channel will be allocated to each of the cluster. And similarly 640 voice channels, if we divide 640 voice channels to 4 clusters, so eventually each cluster will be getting only 160 voice channels. So each cell will be getting 160 voice channels. So for cluster size of n is equal to 4, we will be having 5 control channels in each cluster, as well as 160 voice channels in a cell. One important thing that I would like to point out here is that we only need one single control channel in a cell. Typically one control channel is sufficient, so an alternate representation for this thing could have been that we could have allocated one control channel in each cell and 164 voice channel in each cell. Okay, so this was discussion for n is equal to 4. I want my students to work on the distribution for a cluster size of n is equal to 7 and n is equal to 12, for the case where we have 1 megahertz spectrum allocated for the control channels. So this is end of our today's lecture. In today's lecture we actually briefly discussed the cellular concept, and we discussed that this cellular concept helped us improving the capacity of wireless system by providing a mean of reusing the frequency in the coverage area, and this reuse is obtained by dividing the entire coverage area into small cells with smaller base stations. Okay, thank you all, and we'll stop here for this lecture.